Greetings, A-level chemists. So here we've got a titration curve question, which is a follow-on question from where we had to calculate the pH of a weak acid, propanoic acid, and we're going to write that value down. So we calculated this previously, but we said the initial pH of propanoic acid was 2.98. So that was the initial pH, okay? And what we're doing is we've got the propanoic acid in a conical flask, we're doing the titration, and sodium hydroxide is being added to the propanoic acid. Okay, and then what we did is we worked out what the equivalence point volume of sodium hydroxide would be, and we said the volume of NaOH at equivalence point equals 20.3 centimeters cubed, and we worked out what the final pH would be. So we said the final pH equals 12.55 because we've got excess sodium hydroxide there. Okay, really nice question because it structures it so that the calculations lend themselves to draw the graph. Okay, so what I'm going to do here, I'm going to start by looking at the initial pH. So the initial pH is 2.98, and what I'm going to do just as a guide is let's put some markers down, okay, to help us. So 2.98 is roughly around there, give or take. All right, then the equivalence point is the vertical section, so about 20.3, which is around here. And then the final pH is 12.55, so roughly around here, maybe a bit lower down. Okay. Now this actually helps us. These are markers or guides of the important parts of the graph. So let's go. So our initial pH is going to be 2.98, and when we start adding sodium hydroxide, the pH is going to go up. So there's an initial change in the pH, and then it stabilizes, okay, and rises. It's near flat, but then it starts rising, okay, and then at the equivalence point, bang, we get a rapid change in the pH and it shoots up, and then levels off again past the equivalence point. And make sure this is up to 45 centimeters cubed of sodium hydroxide. Okay, lovely. That looks pretty nice actually. So where are the marks coming from? The first mark is coming from this section, going up and then being relatively flat or rising slightly, then a vertical section, and then slight rise, flat section. That's one mark, okay? Right. What's next? Okay, so what's next? Let's get rid of these markers actually. Let's get rid of that one. So what's next is that this vertical section has to be between I think it was 7 and 12. I'll just double check. So this vertical section has to be within the extremes of 5 and 12, which it is. Okay. Great. So second mark sorted. Okay, so the third mark is coming for correctly relating the equivalence point to the calculation, so it should be at 20.3. Okay, sorted. So that's just for 3 marks, okay? Done. Nice question, I like it. And then a follow-on from this is, well, what indicator should we use for this titration? Well, rather than being biased by the question, we want the indicator to change color in this middle section, okay? In this vertical section. So that's where we want the indicator to change color. So let's just see what we're looking at, because that's going to give us our pH range. Okay, lovely. Okay, so we're looking for a pH range for the indicator between around, actually this one should probably go up a bit. Let's say between 6 and 11, something like that. I'm going to bring this one down. Okay. pH range between 6 to 11.5 or something like that. Okay, let's have a look at if we have any indicators that match. Okay, yeah, absolutely. So Cresol red is too low down in pH. Bromophenol blue is too low down in pH. Indigo carmine is too high up. So therefore, Cresol purple is the indicator that we need. And the reason for that is the color change of the indicator is within the pH change or the vertical section of the graph. So you get 1 mark for saying Cresol purple because the color change is within the vertical section of the titration curve and matches the pH change. Okay, so matches the rapid change in pH. So it tells us when the equivalence point is because you get that change in color. Okay, thank you for watching. Hope that was helpful. Ta-ta.